Hello, this is the video of example 2 for Geometry Topic 1, Lesson 4. Use inductive reasoning to make a conjecture. A conjecture is an unproven statement or rule that is based on inductive reasoning. It's a guess. Educated guess. What conjecture can be made about the number of dots in the nth term of this geometric pattern? Now, what do they mean by nth term? That means like if you somehow want to know how many are in the ninth term, you could just plug it into a formula. We're going to create a formula that has an n in it. All right. Term number 1 has 2 dots. Term number 2 has 6 dots. Term number 3 has 12 dots. Term number 4 has 20 dots. We're going to look for a pattern. Notice that the number of columns is 1 more than the number of rows. So like this is a 4 by 3. This is a 5 by 4. I think you might already know what the next one is going to be. You can see the pattern already. But let's look at their solution. Write an algebraic expression. Oh yeah, because we need to come up with for n. We need to relate like the 3 to the 12 and the 4 to the 20 and the n at the 2 to the 6. We need to relate that. So the term is n, and it turned out that was the number of rows. Let's check that out. 1 row, 2 rows, 3 rows, 4 rows. Yep. And then the number of columns was 1 more than that. So we have the term was n, the rows was n, and the columns were n plus 1. So the total number of dots is the product. Yeah, it's set up like a rectangle, so you just multiply those two. Let's see if that was true every time. Yeah, it was 3 times 4 for 12. 4 times 5 for 20. So our formula for n is going to be the n times n plus 1. N times n plus 1, or then they distributed and got n squared plus n. That's what we need to do. That might be the tough part for some of us, is to relate it. We want to relate it to the term. Let's see what we got next. All right, jump right in for one of them for you to try. This is strange. It's got one less. That's not a full row on the top. Huh. Okay. Let me go down to this question here. They want us to figure out the 5th and the 6th, and then come up with a conjecture for the nth term. That's the formula part. So if you want to, hit pause, give it a shot, and then hit play when you're ready. I'm going to try to look for some patterns. The first term has 1 dot. The second term has 5 dots. I'm not seeing a pattern there yet. The third one has 3, 6, 9, 11 dots. The fourth one has 4, 8, 12, 16, 19 dots. You know, that's really close to what we had before. If you recall, before we had 2 and then 6 and then 12 and then 20. It's 1 less than that. So I think I'm going to use that. It's 1. Remember what it was before? It was the term times the rows had 1 more than that. I don't know where that got canceled. Which I kind of have, except it's going to be -1. That's going to be my formula. That's my guess. And maybe you saw another way to get it, but let me write down how many dots there are again. There was 1 dot, and then there was 5 dots, and then there was 11 dots, and then there was 4, 8, 16, 19 dots. Now, I guess I didn't have to do that for the formula. I could have noticed this pattern. It's going up by 4, 6, 8. It's going up by 4, 6, 8. The next one's going to go up by 10. The next one's going to go up by 12. Right, remember that from the previous example, the previous lesson? It was, we can see how much it's going up by. It's going up by 4, 6, 8, and then I think it's going to go up by 10 and then 12. And I think this is going to be my formula. Let me try that out. 1, 2, 3, 4, 5, 6. Let me plug in a 6 for n and see if I get 41. If I plug in a 6 for n, will I get 41? Showing a lot of steps here. 6 times 6 plus 1. 6 plus 1 is 7. 6 times 7 is 42. 42 minus 1 is 41. I think I got it. Except I answered the second part here. What conjecture can you make about the number of dots in the nth term? That's my answer right here. I already did that. For some reason I did that first. But my two answers are 29 and 41, and then this thing here. They say it's 29 and 41, and for the formula, oh, I forgot, they probably distributed and combined like terms. Yep, they did. N squared plus n minus 1, which is what I have, except I didn't distribute and combine like terms. So, there it is. Let's see if there's another. I don't think there's another example or problem. I mean, there's another example. Okay, so that's it for example 2. Let's find the problems you can do now. After doing this example, you should be able to attempt problems 7, 12, 21, and 22. Thanks for watching.